हेलो फ्रेंड्स, अस्सलाम वालेकुम। कैसे हैं सब? वी आर here again to solve the dynamics problem, that is a 12.2. So the problem is what a small projectile is fired vertically downward in a fluid medium with an initial velocity of 6 meter per second. This is the initial velocity with which the projectile is fired. Due to the drag resistance, the projectile experiences a acceleration during its motion. It due to the drag resistance, the resistance of the air, it experiences an acceleration and a negative acceleration, that is what a is equal to minus 0.4 v cube meter per second square. This acceleration is a function of the velocity. Determine the velocity. So what we have to calculate the velocity and the position after 4 seconds. After 4 seconds, when the projectile is fired, we have to calculate the position and the velocity of the projectile, that at what position and with what velocity the projectile is moving downward after 4 seconds. So this is our data. This is the initial velocity, the acceleration, and this is what we have to calculate. So as we know, acceleration is a function of velocity. So we have given this function, so we put this value, that is what minus 0.4 v cube is equal to dv upon dt. Now by separating variables, we will get dt equals to dv upon minus 0.4 v cube. Now we have to calculate the velocity. So for this we will remove this derivative by taking integration on both sides. So here is 1, the integration of 1 will be t is equals to this time from 0 to t seconds, and the velocity from 0 to v meter per second. So this is our boundary position. So by the derivative of this one is what, minus 0.4 is the our constant. We will move it here, and the derivation of this function is what, v minus 3, we add 1 in power and also divided by this from 0 to v. So t 0 to v minus 1 upon 0.4. So this will become 1 upon v square and minus 2. 0 to v. So now we put these upper and lower positions on both sides. So that will be t minus 0, and on the other hand, both of these 1 upon 2 and 1 upon 0.4 are constant. So this minus and this minus should be replaced with plus and 0.8. We will put the upper value and lower value. 1 upon v square minus 1 upon 0 square. These are, it is t is equals to 1 upon 0.8. This term will become 0, and this is what, oh sorry, we have missed something here. The initial velocity is what, 60 meter per second. So the initial position is what, 60. So the lower limit is 60. We will put here the 60 square. So this will become t is equal to 1 upon 0.8 1 upon v square minus 1 upon 60 square. Now this will move to this side in product. So 0.8 t is equals to 1 upon v square minus 1 upon 60 square. So this term will move to this side and will become 1 upon 60 square is equal to 1 upon v square. Now to remove this square, we will take square root on both sides. So this will become 1 upon v, and this should become square root means 1 upon 2. By reciprocal of this side v, and this will be changed into minus 1 upon 2. Now we have to calculate the velocity at when time is equal to 4 seconds. Now we put the value of t here, 0.8 into 4 plus 1 upon 60 square whole 1 upon 2. So v is equal to 0.8 into 4, this becomes 3.2 plus the square of 60 will become 3600 minus 1 upon 2. So v will be equal to 0.559 meter per second. This is our velocity. Now this is our velocity. Now we have to calculate another thing, that is what the distance, the position of the projectile after 4 seconds. For this, we know that in our previous example we have studied it, that calculate this distance, we know that ds upon dt is equal to v. The derivative of distance with respect to time is what? That velocity. Now as we have calculated the velocity function here in terms of t, that this is the velocity function that we have calculated here. We put now the value of this function. So this equation will become 1 upon 60 square plus 0.8 t whole minus 1 upon 2. Now by separating variables, now simply to remove this derivation, we will take integration on both sides. The distance varies from 0 to s and time varies from 0 to t. So the integration of 1 will be s, and the integration of this whole, this is a constant term, and so this is a power function. The integration of power function is what? Here we use the time function, that we have calculated here, that the t is equal to this one. We put this here. So now the integration of this term will be v reduction in power. This will become 1 upon 2 and divided by the string term. Here is 0.8. Limit 0.8. This 2 will become and 1 upon 60 square plus 0.80 1 upon 2, and this term, this is it. Now we put the values for upper and lower limit. These are the constants. First of all, you put upper limit plus 0.8t this is our upper limit minus lower limit. So what is our lower limit is 0. 1 upon 60 square, this term will become 0, so we don't neglect this. So s is equal to 1.04 1 upon 60 square plus 0.8t whole square root minus 1 upon 60 square. So we have to find the distance when t is equal to. For now, we put the value of t in this equation to get the distance. So s is equal to 1 upon 0.4 1 upon 60 square plus 0.8 t is what 4 whole power 1 upon 2 minus 1 upon this 2 is cancelled by this square 1 upon 60 so we have now we made calculations. 1 upon 0 plus the current is 3.2 power 1 upon 2 minus 1 upon 60 0.4. So this term will be 1 upon 3600 plus 3.2. This whole term will become 3.2 power 1 upon 2 minus 1 upon 60. So the square root of 3.2 is 1 upon 0.4 1.7 minus 1 upon 60 will be equals to 0.016. So this will become 1.7 minus 0.016. So it will become 1.684. Now we divide this term by 0.4, so if we get the acceleration, that is acceleration is equal to 4.21 meter. We will get the distance, that is 4.21 meters. That will be our answer. So friends, if you like my video, then subscribe my channel, and if you have any query, you may ask in comments. So hit the bell icon for more videos about engineering dynamics. Allah Hafiz.